Hello everyone, welcome back to OR2. We are still in network models. On the previous video, we discussed the terminologies that we use in network models. Uh, on this video, we will start with the first problem in network models, which is the minimum spanning tree problem. Uh, so we start with this one, with the first one. That is the minimum spanning tree problem. Okay, what is the minimum spanning tree problems? So in a minimum spanning tree problem, we want to connect nodes, okay, using arc, and we can do this directly or indirectly. So since the connection between nodes can be direct or indirect, and therefore in the network we gonna have what we call as the a spanning tree. Okay, a spanning tree. Okay, and that's why we call the problem as the minimum spanning tree problem. And I think I missed the minimum here. The minimum means, so the minimum spanning tree problem, this is the spanning tree, so we connect all nodes, okay, using arcs directly or indirectly. And the minimum means so we want the total distance as low as possible, or at its minimum point or value. Okay, so that's a minimum spanning tree problem. So I repeat, in a minimum spanning tree problem, we want to connect nodes using arcs directly or indirectly. And remember, what I mean by nodes here, that means all nodes. So all nodes must be connected directly or indirectly, and we want the total distance or uh, or the total length, okay, the total length of the nodes, of the arc, sorry, is at its minimum value. So here here I use distance, but it can be distance or it can be cost. Okay, so that's a minimum spanning tree problem. So I will give you I will repeat the example of a spanning tree. So let's assume that we have 5 nodes. Okay, so 1, 2, 3, 4, and 5. So we have 5 nodes, so I will label it as 1, and this is 2, 3, 4, oh, sorry, 4 and 5, and we're gonna connect them. So this is a spanning tree because we have 5 nodes and all are connected directly and indirectly. See, there is no arc between 1 and 4, but 1 and 4 are connected indirectly. So it is not connected directly, but they are connected indirectly, because I can go from 1 to 4 by going from 1 to 2, from 2 to 5, and from 5 to 4. Okay, there is no connection between 3 and 5 directly, but indirectly there is a connection between 3 and 5. I can go from 3 to 2 and from 2 to 5. So this is a spanning tree. Okay, this is what we call as the spanning tree. And in the minimum spanning tree problem, we want the total distance of the node of the arc. So we want the total distance of the distance of this arc plus this one and plus this arc to be minimum. So that is the minimum spanning tree problem. So examples of the minimum spanning tree problem in the real life can be for example, we want to develop a network of highway, okay, connecting cities, for example, and we want the total distance of the highways that we construct to be minimum. Okay, so in this example, let's assume that we have 5 cities and we want to connect the 5 cities directly or indirectly by using highway, for example, and we want the total distance of the highway to be minimum. And in order to determine the connection between the cities, so we can use we can see this problem as a minimum spanning tree problem. Okay, and this is the concept of the minimum spanning tree problem. Now I will give you an example of a minimum spanning tree problem and how to get the minimum spanning tree from a network. Okay, this is the example. I get the example from the textbook and from Taha, that's the author of the textbook. Okay, so Midwest TV Cable Company is in the process of providing cable services to 5 new housing development areas. Okay, so the figure below, this is the figure, describe a possible TV linkage among the 5 areas. The cable miles are presented on each arc. So from 2 to 5, the distance is 3 miles. From 2 to 3, the distance is 6 miles. Determine the most economical cable network. So this is a minimum spanning tree problem because we want to connect the villages by using cable, and we want the total distance of the cable to be minimum, and the connection between villages using that cables that can be directly or indirectly. And see that there is no arc between 5 and 6. If you find that in a problem, that's mean there is no way to make a direct connection between the two nodes, or mathematically we can see that the cost of establishing the connection between 5 and 6 is very, very high, or it is infinite. Okay, now let's solve this problem and let's get the spanning tree for the problem, and that spanning tree must have the lowest total distance of the cable. Okay, now so we start from node number 1. Okay, so that's what we can do. We start from node number 1. Why I start from node number 1? Because it is number 1. But do we always have to start from node number 1? No. You can start from node number 2, number 3, number 5, number 4, and so on and so forth. I just choose number 1 because it is number 1. But it is not always. You can also start from node number 2, number 3, number 4, number 5, and number 6. Okay? Now, let's label C as the connected node, connected node. Okay, connected node. Okay, and we label C bar as the non-connected nodes. Okay, since we start from node number 1, then our initial C is 1. Okay, and our starting C bar is 2, 3, 4, 5, and number 6. Okay, now the thing that we're gonna do is that we're gonna update C and C bar. Okay, so we're gonna have a new C and we're gonna have a new C bar. Okay, we'll start iteration number 1. Okay, so this is the C is 1 and C bar is 2, 3, 4, and 5, and 6. We call it as the initial. This is the initial step. Okay. Okay, now we start from iteration 1. So this is our C, node number 1. The thing that we need to do is that we need to find, shortest distance from C. Okay, since our C is 1, node number 1, what's the shortest distance from 1? It is 1, right? And that is the distance between 1 and 2. Okay, so we need to decide among 1, 9, 5, and 7, and of course 1 is the minimum distance, and that distance connecting 1 and 2. Okay, so the thing that we need to do, that's now we update C. Now our C now is 1, 2. So that means we connect node 1 and node 2, and we update C bar. I think so. C, I update C, that is 1, 2, and C bar now is 3, 4, 5, and 6. Okay, so from iteration number 1, this is the connection that we have. Okay, so we connect 1 and 2. Okay, that's what we have from iteration number 1 and 2, and this is the first connection that we have. Okay, and the distance is 1. Okay, now we have to repeat this iteration until all nodes are in the C and there is no node in C bar. Okay, or that means until we connect directly and indirectly all nodes. Okay, now we do iteration number 2. Okay, we do iteration number 2. Okay, we need to, so 1 and 2, right? We need to find the shortest distance from 1 and 2. Okay, so 1 and 2 is connected, so we have 9, 5, 7, and we have 4, 6, and 3. Okay, so the shortest distance is 3, right? So 3 is connecting 2 and 5. Okay, I repeat. So our C now is 1 and 2. 1 and 2 is connected. So from 1 we can go to 5, and that is 9. We can go to 3, that is 5, and we can go to 4, and the distance is 7. From 2 we can go to 5, that is 3. We can go to 3, that is 6, the distance, and we can go to 4, and the distance is 4. So the shortest distance among the distances that we can go from 1 and 2, and that is 3 miles, and that connects 2 and 5. So now my C, or my connected nodes, will be 1, 2, and 5. Okay, and my C bar now is 3, 4, and 6. Okay, and what is my updated network? And that will be, I need to connect 1, 2, I need to connect 2 and 5. Okay, so this is set, and this is 5, and I connect it. Okay, and the distance is 3. Okay, I think I will need this picture. Okay, I'm just gonna copy it over here so I can see it clearly. Okay, now I will start iteration number 3. Iteration number 3. So remember, my C is now 1, 2, and 5. Now I need to update my C. So 1, 2, and 5. What is the shortest one? From 5 I have 9. Oh, no, from 5 I have, so 1, 2, and 5, they are connected. So from 5 I have 8 to 4, and that is it, because I cannot do from 5 to 1 because 1 and 5, they are in C right now. Okay, so let's see, from 2 to 4 it is 4, and from 2 to 3 that is 6, and there is no connection between 2 and 6. From 1 to 3 that is 5, from 1 to 4 that is 7, and there is no direct connection from 1 to 6. So the shortest distance is from, that is to 4, right? So from 2 to 4. Okay, so this is the shortest one. So the shortest distance between the connected nodes to the non-connected nodes. So the shortest distance between the element of C and the shortest distance between the element of C bar, and it is from 2 to 4, and the distance is 5. So I'm gonna update my C. That's gonna be 1, 2, 5, sorry, 5 and 4, and my new C bar will be, let me see, so 3 and 6. Okay, I'm gonna update my network, so I'm gonna need this guy. Okay, so this is from 2 to 4. Okay, let's see, 2 to 4, so this is 4. Okay, and this is the connection, and the distance is 4 miles. Okay, now the next iteration, I need to do iteration number four. This is iteration 4. Number 4. So C, what is my new C? So I need to find the shortest distance between 1 to 5 and 4 to 3 to 6. And this is the direct connection that I need to find. From 1 to 3, that is 5, and there is no from 1 to 6. From 2 to 3, that is 6. From 2 to 6, there is no connection. From 5 to 3, there is no connection. From 5 to 6, there is no connection. From 4 to 6, that is 3. From 4 to 3, that is 5. So the lowest is this one, 3. So I need to add node number 6 to the C. So it will be 1, 2, 4, 5, and 6. Okay, and my new C bar is that will be 3, the only one. Okay, so what is my updated 3? This. Okay. So I need to add node number 6. Okay, this is node number 6, and it is from 4 to 6, and the distance is 3. Now I think this is the last iteration that we need to do. Okay, I think I need to copy this to see the distance. Okay, so so the last iteration, that is iteration number 5. Okay, so remember the last there is only one node that is not connected, and it is node number 3. And 1, 2, 5, 6, and 4, they are now connected, and they are the member of C. So from 1 to 3, that is 5. 2 to 3, that is 6. 4 to 3, that is 5. 6 to 3, that is 3. And there is no 5 to 3. Okay, so the shortest distance to 3, that will be from 4 to 3 or from 1 to 3. Okay, so the distance is the same. They are 5. So we need to choose which one that we need to choose. It doesn't matter. Okay, it doesn't matter. You can choose anything that you want, since they have equal value. So in this case, I will select the R connecting 1 and 3. So my C will be 1, 2, 4, 5, 6, and 3. Right, and my C bar will be empty. Right, so that will be empty space. Okay, and what is my updated network? So I'm gonna copy the tree, not connected network, but the tree that I have. So this is the previous tree that I have. Now I decide to connect 1 and 3. Okay, so I'm just gonna put it over here, I think. So this is number 3, and this is the arc that I select. Okay, and the distance is 5. Okay, so we stop because now our C bar is empty, and all nodes that we have in the network, they are now in C. So the last thing that we need to do is to calculate total distance, and that total distance will be 1 plus 3 plus 4 plus 3 plus 5, and that is 16 miles. Okay. Sorry, I missed the S over here. So the distance is 16 miles. So this is the network or the spanning tree of the cable that TV company need to construct. I think this is it for the minimum spanning tree problem, and thank you very much.